Hello and welcome to Astronomy Daily, your daily dose of everything happening in the cosmos. I'm your host, Anna, and I'm thrilled to bring you today's roundup of the most fascinating developments in space and astronomy. We've got an action-packed episode for you today. We'll explore China's latest achievements with their methane-powered rocket launch and their upcoming asteroid sample return mission. Then we'll dive into some intriguing Mars mysteries, as scientists may have finally solved the puzzle of those strange dark streaks on the Martian surface. Plus, we'll uncover the truth behind that mysterious light streak that appeared over U.S. skies during a recent aurora storm, get updates on SpaceX's busy Starlink launch schedule, and check in with NASA's Perseverance rover as it explores an ancient region on Mars that could hold clues to the planet's watery past. So stick around as we journey through today's most exciting space news right here on Astronomy Daily. China has made significant strides in the commercial space race with Beijing-based Landspace Technology, successfully launching their Jukui 2E Y2 carrier rocket last Saturday. The rocket blasted off from the Jukui Satellite Launch Center in northwest China at 12:12 p.m. local time, marking the fifth flight for the Jukui 2 series. What makes this launch particularly noteworthy is that Landspace is doubling down on methane as a rocket fuel. In fact, the company made history in July 2023 when it became the world's first to successfully launch a methane liquid oxygen rocket, beating out major competitors like Elon Musk's SpaceX and Jeff Bezos's Blue Origin. Methane is gaining popularity in the aerospace industry for good reason. It's considered less polluting than traditional rocket fuels, offers enhanced safety, and comes with a lower price tag. These advantages make methane particularly well-suited as a propellant for reusable rockets, which is exactly what Landspace is working toward. Saturday's launch successfully deployed 6 satellites into orbit, showing progress from their previous launches. Their first successful methane-powered launch didn't carry any real satellites, while their second launch in December 2023 managed to place 3 satellites into orbit. This latest mission carried payloads developed by Chinese firm SpaceD, including a radar satellite, 2 multispectral satellites, and 3 satellites for scientific experiments. This launch included some technical improvements that will support Landspace's reusability goals. The company implemented a new propulsion method that involved chilling both liquid oxygen and methane below their boiling points to boost thrust. Landspace founder and CEO Zhang Changwu has indicated that the company is actively developing reusable rockets with test launches expected in the second half of 2025. The race to develop reusable rockets has intensified since SpaceX demonstrated how they can dramatically lower costs for launch vehicles and space transportation. Chinese commercial space companies have been particularly active since 2014, when the government opened the industry to private investment, with Landspace being one of the earliest and best-funded entrants in the field. In more news from China today, China is ramping up its ambitious space exploration program with the upcoming launch of the Tianwen 2 asteroid probe, scheduled for late May from the Xichang Satellite Launch Center. After being transported to the launch area on May 14th, the spacecraft is currently undergoing final inspections before its historic journey begins. This mission represents China's first attempt to collect samples from interplanetary space, marking another significant milestone in the country's rapidly advancing space program. The primary target is asteroid 2016 HO3, a small 100-meter asteroid that follows a unique orbit around Earth as what scientists call a quasi-satellite. While it doesn't orbit Earth directly like our moon, it follows a path around the sun that keeps it as a constant companion to our planet. Once Tianwen 2 reaches its destination, it will deploy a mechanical arm to scoop up dust samples from the asteroid's surface. But the mission doesn't end there. The spacecraft will also explore Comet 311P, providing an unprecedented opportunity to study 2 distinct celestial bodies during a single mission. This sample return mission follows in the footsteps of similar successful ventures by other spacefaring nations, including the United States and Japan, who have previously landed on asteroids. However, this represents China's first venture into asteroid exploration and sample collection. The Tianwen 2 mission comes on the heels of China's impressive achievement earlier this year with the Chang'e 6 lunar probe, which made history as the first mission to bring back samples from the moon's far side. This consistent progress demonstrates China's growing capabilities and determination to establish itself as a leading space power. Looking ahead, China has already announced plans for Tianwen 3, an even more ambitious mission scheduled for around 2028 that aims to return samples from Mars. These missions reflect the intensifying space race between China and the United States, as both nations accelerate their exploration plans with increasingly sophisticated missions. The upcoming Tianwen 2 launch will be closely watched by the international scientific community, as the samples it returns could provide valuable insights into the composition of asteroids and the early solar system, potentially offering clues about the origins of life on Earth. Next, let's take a look at the first of two stories we have today from the Red Planet. Dark streaks that mysteriously appear on Martian slopes have puzzled planetary scientists since they were first observed in the late 1970s. These features, known as slope streaks, are typically darker than their surroundings and can extend for hundreds of meters down steep terrain. In 2011, researchers discovered similar but shorter-lived features called recurrent slope linii, or RSL, triggering an intense debate about their origins. For decades, scientists have been divided on whether these streaks are evidence of something extraordinary, liquid water flowing on the Martian surface, or merely the result of dry processes like dust movements. A new study published in Nature Communications may have finally resolved this long-standing mystery. A big focus of Mars research is understanding modern-day processes on Mars, including the possibility of liquid water on the surface, explains Adamas Valentinus from Brown University, who co-authored the research. The water hypothesis suggested that small amounts from buried ice, subsurface aquifers, or unusually humid air could mix with salt to create briny flows capable of persisting even in Mars's freezing conditions. To settle the debate, Valentinus and his colleague Dr. Valentin Bickel from the University of Bern used machine learning to create the first global catalog of these features. After training their algorithm on confirmed slope streak sightings, they analyzed over 86,000 high-resolution satellite images, identifying 500,000 individual slope streaks. Once we had this global map, we could compare it to databases of temperature, wind speed, hydration, rockslide activity, and other factors, says Bickel. Then, we could look for correlations over hundreds of thousands of cases. Their findings were conclusive. These features appear more frequently in areas with above-average wind speed and dust deposition, factors that strongly suggest a dry origin rather than liquid water. Neither type of streak shows associations with factors you'd expect if water were involved, such as specific slope orientations, high humidity, or temperature fluctuations. The researchers concluded that slope streaks most likely form when layers of fine dust suddenly slide off steep slopes, while RSLs are more commonly found in places with frequent rockfalls and dust devils, those mini whirlwinds of dust and grit that dance across the Martian surface. Our findings suggest that Martian slopes currently do not experience seasonal transient flows of liquid water or brines, underscoring the dry, desert-like nature of Mars, the authors write. This conclusion has important implications for future Mars missions, as it suggests these areas are unlikely to be habitable environments, potentially easing planetary protection constraints for landed missions targeting these regions. Meanwhile, a mystery back here on Earth. On the night of Saturday, May 17th, skywatchers across the United States were treated to an unexpected light show. A brilliant stream of whitish light stretched across the night sky, visible as far south as New Mexico. With a major auroral display already underway due to solar particles hitting Earth's magnetic field, many observers initially thought they were witnessing STEVE, that's the strong thermal emission velocity enhancement, a rare aurora-adjacent phenomenon that creates white-mauve streaks in the ionosphere. But this wasn't STEVE at all. Astronomer Jonathan McDowell, who specializes in tracking activity in Earth orbit, quickly identified the true source, a fuel dump from the upper stage of China's Jukui 2 rocket, at an altitude of about 250 kilometers. As reported earlier in the show, just hours earlier, at 4:12 UTC, Beijing-based startup Landspace Technology had launched their Jukui 2E Y2 carrier rocket, carrying 6 satellites into orbit. The striking visual effect occurred when the rocket's upper stage released unused methalox fuel, a mixture of methane and liquid oxygen, while passing over the southwestern United States. At that altitude, right in Earth's ionosphere, the fuel created a chemical light show through reactions with the charged plasma environment. According to physicists, these reactions can include ion-molecule charge exchange, electron-ion recombination, and optical emissions from chemiluminescence. In simpler terms, when rocket fuel interacts with the ionosphere at night, it can create a long-lived glow visible from the ground. While we've seen rocket fuel create strange spirals in the sky before, this particular manifestation, a straight white streak resembling Steve, appears to be something new. With methalox gaining popularity as a rocket fuel due to its efficiency, cleaner combustion, and potential for in-situ production on Mars, we might see more of these unusual light shows in our night skies in the future. So if you spotted this mysterious streak on May 17th, now you know it wasn't an aurora or Steve, but rather the after effects of humanity's expanding activities in space, bringing a bit of cosmic chemistry right to our doorstep. Okay, moving on, let's take a look at this week's launch schedule. SpaceX is ramping up for an exceptionally busy week, with at least 3 Starlink satellite launches planned across both coasts of the United States. The ambitious schedule reflects the company's accelerating pace as it works to expand its global internet constellation. The week began with a Falcon 9 scheduled to launch Starlink Group 12 to 15 from Space Launch Complex 40 at Cape Canaveral in Florida. However, the countdown was held at just under 2.5 minutes before liftoff. Unlike most Starlink missions, which typically have 4-hour launch windows, this one had an unusually short 35-minute window. The hold resulted in a scrub, as Falcon 9's highly chilled fuel warms too quickly to allow for a reset within the same window. The mission would have carried 23 satellites, including both standard V2 mini satellites and specialized direct-to-cell variants. Later in the week, another Florida launch is planned with Starlink Group 1222 lifting off from the same pad on Saturday. This mission will similarly carry a mixture of Starlink V2 mini and direct-to-cell satellites on a southeasterly trajectory over the Atlantic Ocean. But perhaps the most significant launch of the week will come from Vandenberg Space Force Base in California. On Sunday, SpaceX plans to initiate construction of an entirely new orbital shell for the Starlink constellation with the Group 17-1 mission. This launch represents a major milestone as the first Starlink mission, targeting a polar sun-synchronous orbit at a 97-degree inclination since the earlier Group 3 deployments, which used older V1.5 satellites. The polar orbit will enable Starlink to provide coverage at high latitudes, including the Arctic and Antarctic regions areas that have historically had limited access to reliable internet connectivity. This expansion into polar orbits represents the next phase in SpaceX's plan to provide truly global coverage. All 3 missions will include landing attempts on SpaceX's autonomous drone ships positioned in the Atlantic and Pacific Oceans. These recoveries continue to demonstrate the company's reusability model, which has revolutionized launch economics with some boosters now having flown more than 24 missions. If all launches proceed as planned, SpaceX will surpass 60 missions for 2025, continuing their record-breaking launch cadence and further cementing their dominance in the commercial launch market. Also this week, we have launches planned from China and Russia. The first of several Chinese launches expected this week will launch from Launch Complex 201, LC-201, at the Wenchang Space Launch Site in China on Tuesday, May 20th at 11:50 UTC. There is no information regarding the mission's payload at present, however. The hazard warning notices published indicate that the Changjiang 7A, CZ-7A, will fly due east from the launch site. Another Chinese launch is expected on Wednesday, May 21 at 0400 UTC. During a launch window extending from 0354 until 0415 UTC, a Kinetica 1 will lift off from Site 130 at Jukui Satellite Launch Center in China. Published hazard notices indicate a southwesterly trajectory for the flight. This mission will serve as the first Kinetica 1 mission of 2025 and the 7th overall. And finally, rounding out a busy week of launches, a Russian Soyuz 2.1A with a Fregat M 4th stage will launch an unknown payload on Friday, May 23rd at 0700 UTC from the Plesetsk Cosmodrome in northwestern Russia. This will be the 3rd launch for a Soyuz in 2025 and the 113th orbital launch attempt worldwide this year. Finally today, let's return to Mars. NASA's Perseverance rover is embarking on an exciting new chapter of its Martian adventure, exploring a region that scientists believe could harbor some of the oldest rocks on the entire planet. After spending 5 months investigating Witch Hazel Hill, the nuclear-powered rover has now moved on to a new area of interest, dubbed Crocodillen. The name, which means the crocodile in Norwegian, was chosen by mission scientists after a mountain ridge on Norway's Prince Karls Forland Island. This 73-acre plateau of rocky outcrops sits downslope to the west and south of Witch Hazel Hill on the lower slope of Jezero Crater's rim. What makes Crocodillen particularly tantalizing is its geological age. These rocks formed before Jezero Crater was even created, dating back to Mars's earliest geological period known as the Noachian era. In fact, they're among the oldest accessible rocks on the entire Martian surface. An early investigation of the region revealed the presence of clay minerals, which require liquid water to form. This provides compelling evidence that abundant water once flowed across this ancient landscape, long before an asteroid impact created Jezero Crater. Clay minerals are especially important in the search for past life because they're known on Earth to preserve organic compounds, the fundamental building blocks of life. Ken Farley, deputy project scientist for Perseverance, explained the significance. If we find a potential biosignature here, it would most likely be from an entirely different and much earlier epoch of Mars evolution than the one we found last year in the crater with Chayava Falls. That previous discovery featured chemical signatures and structures that could have been formed by ancient life. The rover, which celebrated its 1,500th day of surface operations on May 9th, is currently analyzing a rocky outcrop called Copper Cove. Orbital data suggests that other areas of Crocodillen may contain olivine and carbonate minerals. While olivine forms from magma, carbonates typically develop when rock reacts with carbon dioxide dissolved in liquid water. On Earth, carbonates excel at preserving fossilized microbial life and recording ancient climate conditions. The Perseverance team has also implemented a new sampling strategy, allowing some cored samples to remain unsealed. This gives the mission flexibility to replace earlier samples if more scientifically compelling features are discovered down the road. Katie Stack Morgan, Perseverance's acting project scientist, noted, "We have been exploring Mars for over 4 years, and every single filled sample tube we have on board has its own unique and compelling story to tell." As Perseverance continues its methodical exploration of this ancient Martian landscape, each rock it analyzes brings us closer to understanding Mars's distant past and potentially answering whether life once existed on our neighboring planet. Well, what an incredible week in space and astronomy news. We've truly spanned the solar system in today's episode, from groundbreaking rocket launches here on Earth to the mysteries of Mars and beyond. The pace of innovation in space technology continues to accelerate, with China's Landspace joining the race to develop methane-powered rockets, technology that could revolutionize our access to space through reusability and efficiency. Their upcoming Tianwen 2 mission represents another significant step in asteroid exploration, joining efforts by NASA, JAXA, and other space agencies to understand these ancient celestial bodies. Looking ahead, watch for SpaceX's continued expansion of their Starlink constellation, particularly the new polar orbit shell, which will enhance global coverage. The Russian Soyuz launch carrying its mysterious payload will certainly be worth monitoring as well. On Mars, Perseverance's exploration of the ancient Crocodillen region may yield some of the most significant discoveries yet about the red planet's early history. The rover's investigation of those Noachian-era rocks could fundamentally change our understanding of Mars's potential habitability. And the scientific detective work that solved both the mystery of Mars slope streaks and the strange light phenomenon over the United States reminds us that space science is constantly evolving, with new observations challenging our previous assumptions. The coming weeks promise even more excitement as these missions progress and new launches take flight. Our understanding of the cosmos grows richer with each passing day. And that's all for this episode of Astronomy Daily. I'm Anna, and I want to thank you for joining me on this cosmic journey through today's most fascinating space and astronomy news. If you're hungry for more space content, and let's be honest, who isn't? I invite you to visit our website at astronomydaily.io, where you can sign up for our free daily newsletter. It's the perfect way to stay updated on all the latest developments in space exploration and astronomy with our constantly updating newsfeed. Don't miss a single episode by subscribing to Astronomy Daily on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts. New episodes drop daily, bringing you the most compelling stories from across the universe. Until next time, keep looking up. There's always something amazing happening in our cosmic neighborhood. This has been Anna for Astronomy Daily, your daily dose of space news and wonder.